So please try to avoid the questions related to the registration and other things. So this is completely, you can ask question related to the how to do a project, what are the type of projects, particularly related to the research projects. So you can ask professors and make use of the session as good as possible. Thank you. Thank you, one and all.
Sir, it is visible.
Professor, continue, professor.
Yeah, thank
Welcome,
you,
professor.
sir. Thank you, Dr. Ravi Kumar, sir. Is it visible, sir?
Yeah, I can see your presentation.
Okay, sir. Okay, sir. Thank you.
You can
Yeah. I will make it
full slide.
full screen.
You can.
Full screen. Yeah. It's okay. Is audible, sir?
Okay, sir.
Yeah. Thank you, sir. Thank you very much.
Okay.
Good evening, one and all present here. I am Dr. K. Vijayaraja, Professor and Head Department of Aeronautical and Aerospace Engineering, KCG College of Technology, Chennai. It is a Hindustan Group of Institution. It is a part of the Hindustan Group of Institution. I take this opportunity and first of all, I thanks to Dr. Manogar sir and Dr. Ravi Kumar sir, and also thanks to the Yassc and Tass, means Youth Astronomy and Space Science Congress, also Tamil Nadu Astronomy and Science Society members and advisors, then academy peoples who are involved, and my dear students, good evening to one and all. It's my great pleasure to share my PPT with you. Today we are going to discuss about the space technology, the online orientation. Then my topic is the model project, basic model projects for space science and technology. I hope I covered the things in the space debris, space station, and space agree. And most probably, what are the things we carried out in our department by our students and the startup companies. I hope that may be very length. I will make it very short and sweet. You can enjoy. I hope you will enjoy the session, the today evening session. Whatever sir mentioned, Udayan sir mentioned, and Dr. Ravi Kumar sir also mentioned. If you have any doubt, please send message, or after the completion of that one, you can very well ask the questions. I think I will go through this one. This first one, basic project model based space science and technology. And this space technology, about what is the space technology? We are having a lot of query. So most of the time students will ask about that. What is the difference between the aeronautical and aerospace engineering? First, I would like to say within the atmosphere, we started within the atmosphere, that is aeronautical. Above the atmosphere, that means beyond the atmosphere, you can say that space, that is the one space technology. It will give the outer space. We can say that outer space, we can give the space exploration, earth observation, satellite communication, and navigation. Most of the things, whatever we are doing in the atmospheric level, beyond the level also we are trying that. That is why most of the scientists are working in that field. And moreover, I ask all the students community to involve in that one, try to do some innovative things. That is the one. This is beyond our limit. The innovation is very much essential for all of us. And moreover, you think about the scientists, how they are doing that one. So why space technologies? We are needed the is everyone dream, because we know that we are moving in the roadside. Now we are moving in the flight. Now we plan to go for the space. That is why we are doing all the work. And moreover, satellite launching. We are doing all satellites. Because of this one, we are communicating each other. That also very much essential. Then apart from that one, nowadays we are using that AI configuration, artificial intelligence, not only within the globe, beyond the globe also we are doing. That is beyond the space. So I request all the people to involve yourself and try to learn something the new technology. That is very much essential. Exploration versus global cooperation, a shared feature. That is the feature is in your hand that you have to utilize in the proper way. Then space technology. So what is the scope of the space technology? Lot of opportunities available nowadays. Now that aviation field was booming, anything like that, so we are having lot of things in this one. So almost who are like to join in the aviation field, so you have to take it forward and do something innovative idea, because of the space science and technology we are having a lot of opportunity. I will give that small introduction about what we are doing, that is our country is doing. Then after that we will go for the space debris as well as the space station, and moreover that how we are doing in that space agriculture, in that agriculture in the space. Then we will see the project what we did in our college that will help you to motivate to the next level. Space technology, space application, space vehicle technology, outreach. Why? Because means we are having that lot of opportunity. The ISRO is doing lot. You know very well that is we are having the satellites center, the ISRO, and moreover we are launch pad in the Sriharikota. The newly started one Kulasegara that is 1,500 acre, more than 1,500 acre. That's third launch pad is planning to go for that one. That also we are having a lot of opportunities in that for aviation field. Satellite technology, technology for human space, space science and exploration, then space application, satellite vehicle technology, outreach activities. Because a lot of things you can go for that one later on. I can share this PPT also to all of you. It will be very helpful. 60 years in the space technology. You see, lot of things. You can start from the 1964 to 2025. We achieved a lot. You know very well, we are the fourth country in the world, in the globe. Globally, we are the technologically, in the space technologically, we are reached in the fourth place. First one is US, Russia, China. The next we are the one. Very soon we will come as the number one. That no doubt, because we are having the population, and moreover most of our scientists are working not only here, throughout the globe. So if scientists are doing something innovation for our nation, means surely we can come as a number one. That already we are reaching the fourth position. Very soon we will come in that first position. What is the we are having so many international things. Just to think about this, 1958 to 1966 is they started NASA. Now we are reaching that one. We have that 1967, because we have to, thanks to the scientist Vikram Sarabhai and lot most and latest our Dr. Abdul Kalam ji. So we lot of idea and innovative idea, and moreover a lot of space agencies available globally. All are doing their work, and whatever need for their country they are doing lots. Domination is this. Even though we are having a lot of countries, naturally you know very well who are the domination in the world. First one is USA, Russia, China, UK, Japan. Then in that case we are having that France. This is 2020. Now we are in the fourth place. US, Russia, China, now India. So we are reached in the fourth place. So that is the scenario in the space technology. We are having a lot of opportunities in the space technology and improving a lot. And we are moreover we are doing all the things and doing innovative idea and how to reach the Mars, as well as the latest technology we are using that one. What is the contribution in India? So latest milestone in India exploration, it starts from 1963 to 2025. Almost we are having the rocket launch, then formation of the ISRO is 1969 only. The ISRO was formed. Now we launched Chandrayaan, because you know very well Chandrayaan 1 and 2. So we did lot, and Aditya also is waiting, and Gaganyaan. So many things. Just to think about that, you see the things. 63, 69, 75, 80, 84, 2008. So each and every time we are doing some innovative things in the space technology. Chandrayaan 3, you know very well, We are the first country we reached to the south pole of the moon, the Chandrayaan 3. Even the second was failure, but our scientists was work hard and they reached and achieved the things in the Chandrayaan 3 and land on the moon, the south pole. That is a very great thing. No one was reached that place. That is the main important point. And these are the things we are having the Indian space program and national space system. A lot of launch vehicles we did that one. Space commerce, that is a PSLV, GSLV launch vehicles, and satellites, a lot of satellites. It was used for many purpose, agriculture purpose, then communication purpose, meteorological purpose. Then we are having that water resource, where the water is available. And then very soon we are going to go for that moon for the space also. That is a Gaganyaan system, we are using that one. And international collaboration and industry support we are having, and the academic participation. Why you are telling the academic participation? Nowadays that the government is given that opportunity to launch that school students and college students satellites, 75 Atmanirbhar. So 75 satellites they are going to launch. In that, I'm very happy to inform you, we are also one of the members in that one. Very soon we are going to launch one satellite. That also I will show that what is our space center in our college available. So each and every program, so a lot of program we are having that one. The space infrastructure, application, institutionalized and ground segment, capacity building, international collaboration. So anything we can do that one using the space application. That too we are using the 3-side one: LEO, GEO, and MEO. That means low Earth orbit, medium Earth orbit, then geosynchronous orbit. So in that also BSLV, GSLV, ASLV, then SLV is the satellite launch vehicle. That is the one we are doing that one. Then we are using the reusable launch vehicle. So that also we achieved. That's why I'm telling that we are in the 4th position throughout the world. That is very, very important. So 5 decades we are in the space station. So almost we have that 41 satellite from other countries. That is very great things we achieved that one. Not only our country satellite, we are ready to launch other countries satellite. We are supporting even sometimes that needed support from the topmost country also. They are requesting our support or launch, but they are using that one. That is the one. 45 launch vehicle missions and 72 plus spacecraft missions. So we did a lot things. You can see that picture itself: SLV, ASLV, PSLV, GSLV, GSLV Mark 3. So that is the one achieved in the country. We must be the second to none of the application advanced technology in the real problems the man. That is why we have to. That is quoted by Dr. Vikram Sarabhai. That is a very, very important one. Even though you think about it, nowadays we are struggle to do some projects, even small project also we are struggle to do that one. Students try to understand. Even nowadays, I'm very sad to say that one, and very why? Because means students are taking so light-minded, because they don't want to take in depth what we have to do, what we have to learn, because we are reaching the AI, artificial intelligence level. If we give any assignments, is what the students are doing, then chat GPT. That is not work it out. So typing, it may be very helpful for you, but you have to do your own. You have to involve yourself and study and write your own, and whatever the innovative idea, that is the one you have to. Government is supporting the aviation field for anything. If you want to do some entrepreneurship, government is supporting. Not only Indian government, Tamil Nadu government also supporting very well. Easily you can get the fund if you have the innovative idea. Startup, entrepreneurship, that is the one. So this is the lot of missile life cycle from this one: SASC, LPSC, then IASU, VSSC, Yassc, SDC, MFC, then ISTRAC. That is so many companies. There is spacecraft program mainframe. So wherever if you want the propulsion system, payload system, then operation, that is geo Leo, then launch and support services. Then we are having the VSSC, they support almost all the vehicle manufacturing things in that one. And the Sriharikota, we are having the launch pad that will be useful to launch any satellite and rockets. What is the application? Space applications. You see that lot of application. Already I told that communication, navigation, or remote sensing. In that communications, almost what we are doing right now, that is the communications. And disaster, during disaster things we are using that one. TV, mobile, radio, so many things. Navigation. So almost what we are doing that was navigation for aircraft, ships, vehicle, wherever you want to go. That is navigation. Without navigation, nowadays we are using the Google also. That is the navigation purpose we are using. Even sometimes Google will reach some other point. That also so there is a fun element. Something they ought to upload in the proper way. That is will happen. Remote sensing. We are having the agriculture, then forest, water resource, geology, coastal, then environment, rural, climate, and then global change. Global change is the very one. That's why we are nowadays almost we are thinking about the sustainable things that we have to constellate. 17 points is there. Out of 17 points, at least you have to use any one to minimize the heating element. That is the global change. So tele-education, telemedicine. So we are using the satellite for many services, especially for education and health. This is the very, very important. It's look like a two eyes. Whatever we are having two eyes, this is most essential. Education also very, very important. The similarly, health is very health is wealth. Health also very important. For that, we are the space technologies very much essential and very they are helping and very lot support for the education as well as the medical side also. Even from other country to our country, one country to other country, easily we can do some surgery, major surgery or minor surgery, and telepathy. You can communicate through the satellites. That is the very much essential things, and that's why we are telling that the satellite technology is for telecommunication as well as the education side and the medicine side. Gaganyaan. All of you know that Gaganyaan. We are came to know about that through the media, the newspaper. Gaganyaan. What is meaning Gaganyaan? Gaganyaan is the one GPS aided geo augmented navigation. That is a main thing is it will give support for the Indian government. Then we can send that people for the space that we can study about that one. It will helpful to for almost all the transport system. So air, sea, and land positioning application, survey, image correction, GS, timing, surveillance, and fleet monitoring. Any place throughout India and globally, we can do that one. And most of the time, we are supporting the Indian government in the defense sector, especially. And not only this defense sector, then it will be useful for that airport and airlines also. Because this Gaganyaan project is combined with the AI, Airport Authority of India, as well as the ISRO. That combinedly they are doing that one. That will be very useful for our nation. And then satellite application. So what we are having that satellite applications. So already I told that many things we are having that application, water resource, environment, agriculture, then weather, climate, rural. So that also we are monitoring and helping, and especially where is the soil, that is land soil, and where is the particular waters available, the minerals available. So we can't go and judge anything in that one by person. That's why we are having the things in the satellite things. For that reason only we are sending the satellite. It will be helpful for human also, that is fishermen's and the environment conditions, then nature, how the sea conditions available. So it will be very useful and very quickly we can give the information to the people, whether it is good or bad. That is, we will give the information. That is the climatic change, environmental change, environmental conditions. The space science exploration, we are having a lot of support through this one, because the science and technology is very much essential. Without engineering, nothing is available. Even you can say that one, most of the people will tell that medicine, lawyers, and everything, human being, whomever like that, without engineer, there is no instruments, no machines, nothing. That is why we are having the technological importance. And that too, not only the within the atmosphere, beyond the atmosphere, that is a very important things we are using, that astronomy, the space science, and its application for our human being. And moreover, it is will be very useful for astrophysics, stellar physics, astronomy, aeronomy, the planetary atmospheres, earth science, life science, solar systems, and theoretical physics. People, you can have that idea, you can study initially aviation, then after that, if you want, which field you want, either you can go for any particular things, you can select other things, X-ray, gamma rays, then ionospheric, middle atmospheric, equatorial, solar flares, isotropic, and planetary. So many parts available, applications available. We can choose whichever you like. Accordingly, we can go for that one, and you can do your research and innovative idea in that field. That will help for you as well as the nations and the society. That is the most important. What is the challenging missions? We are having a lot of challenging. So already our government has launched a lot of things for in the space. That is the one throughout we are doing a lot of support through the satellite only. We are getting a lot of support. That is one of the idea. Either it may be a payload instruments, and moreover communication, navigation, then agriculture, environment change, water, minerals, everything. Then apart from that one, in future also morphology, topology, and the mineralogy, mass, consider mass. We are planning for the mass also. The astrostat. The astrostat will give support for the sky scanning monitor. So we can have that lot of unity in that satellite. In that satellite, it will give the multi-wavelength astronomy for observation of the galactic objects, any objects in the space, apart from our knowledge, because we can visible whatever we can see in the atmosphere means easily you can see that one. That beyond the space atmosphere, we can't predict anything what is available. We are having doubt whether it is water is available or not. That's why a lot of idea, that lot of innovation, lot of research is going on. That also one of the parts you can involve yourself accordingly what you are having in your idea to get into the aviation field, the aerospace field. Aditya, that latest one. So that is the one nowadays, the talk of the country, the talk of the nation after the Chandrayaan 3. So this is also very important things. We are having that infrared bands, we are doing that one. That is main thing is we are having that coronal mass ejections. That is very, very, very essential to study the subjective of the mission. So that will give the new information on the velocity field and the variability, and then inner what is available in that mass. We are going to do that using the hollow orbit and the sun earth orbit, that L1 point. So I hope most of the things in the TV and other things that scientists and professors levels they are discussing very lot. Very soon it will help us to support what is available in that field, in that area. Megatrophic is. So that also will give us, this is a combination of that, or association of the Indo-French. That is the one, the international level support. We are having almost all the countries, we are supporting and get the support to launch the new ideas and the new innovative things in the spacecraft as a space science. We are having that one. Multi-frequency, we are having that, because nowadays very 4G, 2G. Earlier we talk about the 2G, 3G, 4G, 5G. Now it all reached up to 7G. So whatever, so many G is available, but without G we can't communicate each other. Okay, that is very, very essential. Cartosat, that also will give support for the hyperspectral image. Even we are using the drone technology also, image processing, that we can find out that area, then we can do the image processing, and from there itself we can find out what is the, who are the people available. That also will support for the defense sector, not defense sector, as well as the police and patrolling, and as well as the travel surface. We are using that where we are going. That is the one already I mentioned, that Google will support where you are going. That is a location. So current location easy to identify. That is the one we are having. That is different channels, different bandwidth, then multispectral. So that is the one we are using hyperspectral image, easy to trace or track from space itself. That is the main thing. Then we are having that insert 3D satellite metrology. That so already everything is available. These are key things what the Indian government, the ISRO did so far. That is the one I am showing this one. So not a new one. A new one is already is in the progress. So we will see that one. Docking equipment, latest technology. That's why we are reached in the fourth place compared to any other country. So earlier I told that in space itself we can joining, aligning. So two satellites, you can two spacecraft aligning or joining. That is the randomness. We can say that one very quickly. So joining and the piggyback, you can say that piggyback. So one over another, because initially we do that one rocket ramjet engine. So initially we are using that run. We can have the things up to one certain level. You use the aircraft, then we will go for the space station. That is one piggyback like that. BSLV. So a lot of support. The talking system. We are even the roadside very difficult to join two pieces, but in space people are using that AI, and they are doing that support with the space technology and joining the two satellites in the space. Latest technology we achieved in our country, that is the one talking system, or you can say that space talking. So already I told that reusable or re-entry vehicle. So every time we have to spend a lot of money for using the space vehicle or space capsule. So how to recover that one? That is the one reusable launch vehicle, the re-entry technology, manned mission, microgravity. So sample return mission. That is already that also we achieved by the scientists, ISRO scientists. That also we are having. That's why in aviation, the aerospace field, almost we are reaching the higher level. You are growing once next to the next level. So in future, we may be the number one throughout the world. The space transportation. So almost everyone nowadays, like people are having money, because it may be very cost, but people are very interesting to go the space using the space vehicle. And nowadays our country, that IAF person is going to Mr. Sukla is going to go for that IAS in International Space Station very soon. That is because of that environmental condition. The day is postponing. Very soon he will be in the IAS, that International Space Station, from our Indian person. Even Indian origin already reached this Miss Sunita William, but even from our India, Shukla ji is going to travel in the space station. Mission profile. That is one already told. We can have that lot of idea. So relaunchable, reusable launch vehicles. That is the one by how we are doing that one. So that also we achieved. That Indian human space. That is the one very soon we are going to do this one. So orbital vehicle. So this process is going on. Let us see and pray for that one. We will have to achieve this one. Gaganyaan. Already I told that is Indian space. So we are having that Gaganyaan, human rated things, and test vehicle flights. So very soon it will happen successfully and positively. Parthya Antrakrit station. That's another. This is the one normally we are telling that station, space station. That is international things we are having that one. So through that, most of the things they are doing that talking. So already, so I told no. docking and berthing. That is the things two satellite or two spacecraft joined together. A rollout solar array, that is ROSA, then propellant refueling, servicing. How we are doing that one? Because IAS, that is the one. So 4 countries involved. This almost all the countries they are doing for their own support and maintenance, and they are having two robotic arms that will support and maintain the things. So almost the overall mass is 52 tons, and overall dimensions is 27 meter, 20 meter, and then crew size is 3 to 4 nominal, and maximum we can have the 6 for short duration, not more than 4. So maximum means that is only for any maintenance purpose, and then you have to come back. Then that is a orbit circular around 400, maximum 400 to 450 kilometers. The inclination is 51 point degree. That is the one. So Indian human space flight mission, that is already I told that we are planning to go for that one, and Indian landing on moon by 2040. So that also process in our country is planning to do that one. Then mission, the launcher, a lot of things in the aviation field. So almost Rakesh Sharma, he is the first person. He has reached that place. Indian rulers of scientific missions. So a lot of things here. Chandrayaan 3, Chandrayaan 4, Lubbock's. So these are the ideas. Almost we are reaching Chandrayaan 3. So next we are planning for Chandrayaan 4 and Lubbock's. We are having that joined with the Japanese JAXA that we are having. Chandrayaan is a long duration robotic mission. So robotic mission almost to some of the colleges also supported. I hope one colleges designed for that robotic arm that will support. I hope so. But our government is planning and to do the things. That's why most of the time we are approaching the students, because young minds having a lot of idea, the innovative idea, it will help you. That's why most of the time they are conducting that competition also. Through the competition, they will select the students, and then they will plan to have the idea, whatever they are giving idea, they will execute as a main things. Upcoming is, these are the upcoming things in future. So very soon it will come for all the technology in the process. Is only in the study level. So very soon it will happen. So students also get involved. What are the opportunities we are having in front of us? Try to utilize it in proper way, and try to do some mini project like that. Not that is a the cost very cost. Then even though we try to do something that minimum level, that is why we are doing that. We are motivating the students to do some mini project. Then slowly we can make it as a major project. That is in your final year projects. Already I told that this is a mission profile. So launch vehicle, we are having that launch vehicle. Why we are using that? We are at, already I told that ramjet is scramjet ejector turbojet. So the scramjet is the supersonic combustion ramjet, because that is the one will support to take the things to the space. There is a supersonic conditions. Then this Mach number may be greater than. Nowadays we are using the hypersonic. That is a Mach number more than 5. Lot of research is available. You can go that this very few things is available. So students should involve and identify in which field you want to, or which field you are interested. Accordingly, you can select and try to do some research work. Research work means collect the paper already what is existing. Based on that one, you can compare and what you are having in your idea. That is the one. Research, that is the one. So a lot of ideas available. Even space debris. So that also we can do something in the space debris. That's why I'm going to tell that about space debris. A lot of opportunities available, and it may be a very difficult one. And we have to, only thing we have to innovative idea. If you are having innovative idea, then only you will get into that one. I think you know very well that structurals, architecture. If architecture they are doing something Innovative means that is the one will attract. Like a director, cinema director. Easy, I can say that one. Even though 300 crores and 400 crores they are utilizing, and moreover, latest movie also it came that is very small budget that will attract the peoples. That is very, very important. That is why, even though you are having that cost wise so higher means you can have small idea that will help you to do the project and it will reach the next level. That is the one innovative idea. You have to think and work what we have to do from our side instead of already existing. That is why we are doing that research, research the papers, whatever that earlier people or scientists or professors they did one. So you have to connect and you have to go for the next level using that one with your own idea. This international space station, everyone knows about that. You see that what how the technology was involved. So accordingly, we have to think and at least we have to do something in that our level instead of going for the bigger level, at least small level. And that's why I'm telling that is innovative idea. If you are having innovative idea means government is willing to support to you. I want to move very quickly. The key challenge, these are the key challenge we are having that one. So whatever the disposal, that is waste disposal, lot of things available from small debris to large debris, satellite levels available. That and all how we are going to remove that one. That is Indian government also planning in the 2030, 2030, you have to do something for that one. Lot of technology they are doing that one. And students community you have to involve and you have to think and work and give some idea that will give the support to the government. That is the why you have to make this yourself and participate like this, like society, Yassc and Tass, and moreover, there's a lot of space astronomy club is available. You can involve yourself and give your idea to the club activities as well as the colleges and the professors that will reach there. And you can participate in any competition also, like aviation field, space debris. You see, like what we are doing, the junk food, whatever we are doing, even though people will tell that don't eat like this one, like the same things we are having lot of debris in the space. We don't know how it will going to remove from that space, and that also very dangerous one, like a global change nowadays. That also very dangerous one in the debris. How you do that one? You see, 1957 that it was very clean. One or two, 2005. You see, these are the debris. 2020 we don't know because then that global, that is the things that is the scenario from the picture. So how we are going to, almost all the countries are trying to do some project in this one. Already some of the countries are involving and doing that one. Even small debris, if we remove that means we can reach that we can hit $10 million like that. That's why we can easily involve or we can easily give the support. And even the cost wise we don't worry about that one. You removal of the small debris also, the globally will get the support for financially. You can get the funded project. So that is the one, Leo, Mio, Geo. So almost we are having that very small, about US tracks about 2022 object in the Earth orbit. So that is working satellite 1000 is there, and 21,000 debris greater than 10 centimeters. So there is a one I'm telling that very small debris is the very dangerous one. It will come and get the object is immediately danger. That is like you can say that the space bird hits in the aircraft. Even small bird will hit the aircraft, means it will totally damage. You may ask questions how it is possible because of that one, because very high speed and moreover engine side it will have the means that blades are high temperature. Even small part or small component will hit, that means the blade will damage, the engine will damaged. That is the things we are having. Like that only small debris and all very much danger for the object. No active collision evidence. There is a not a possibility, but in the within the atmosphere is possibility. So total mass is 66,300 tons is available. So you have to think about that then. So debris sources, we are having a lot of sources here: arbitrary deorbit, retrieval, accidental, deliberate, collision, explosion. So people are, and globally they are thinking and how we have to do the rectify the things and how to remove the debris. So you see things. So how it was 2025, slowly the total object is increasing. So very much number of object almost 26,000. So we are going to reach the 26,000 number of things. So how we are going to remove that one? You the students community, you have to think and work and you have to do some project. There is space shuttle vulnerability. That also one part. Another part is international space station vulnerability. So many things available. Yeah, through the international space station also they are trying to do something and try to capture the debris and try to remove the things. The risk tolerance is 24% for probability of the penetration for 10 years. So these are the things. Even if we see the total siding mass is 23,000, almost we told that 26,000. It may reach in the 25. And small particle impulse, that is a very small particle. We are also that ISS, International Space Station, they are trying to capture that things. They are doing some arm, that means robotic arm. They are having that one. They will support for the maintenance purpose. Also, you will have support for the removal of the things. Everything is the low orbit only. That is LEO. Active debris. These are the points we have to discuss because students can easily take any topic and you can study and do research and submit your project for the government. Surely you can get the fund. That is active debris removal, laser ablation from ground station earth to space or from space station to that debris. That is the one. Magnetic coupling, sweeping, what we are doing, that sweeping, that also possibility. Foam and aerogel, easy to catch that one. And thrust and capture vehicle and tethers and tentacles and basket, net and sail and whatnot. So we don't know idea. So whatever you are having in your mind, you can put and you can get the fund project for removal of the debris. The challenges, what you are having the challenges. So apart from that, whatever we are having that already I told you know. So active debris removal. So we are having a lot of challenges. So many things we have technical challenge, then little economic incentives, and then no internationally agreed definition for space debris. So we don't have any idea. Even other countries also don't have any idea. But only thing, they are doing their own way. That is innovative idea for each and every country is trying to remove the things as their own life, one way of innovative idea. That is why I'm telling students also get involved and do some research project how to remove the space debris. Almost 95% in the space chunk is available. Clear the space and spin off from the things, and a lot of countries involved. I already told that each and every country they are trying their own way. That also our country also trying for that one. So get involved and try to do something for the nations. Space debris monitoring, that also we are doing. So almost all the countries we are doing. Share my space, the French we are country, they do that one. And lot of things available in the website. 90 lakhs, sorry, 9 lakhs debris between 1 and 10 centimeter. So I told smaller things less than 10 centimeter is the very dangerous compared to the bigger size one. So it will surely it will affect the near future whatever we are going to launch in the space. Astragal and Orbit. These are the one startup company, the Japanese startup company. So they are doing a lot for that one. And JAXA, the Japan Aerospace Exploration, that is a JAXA. They are working removal of the Japanese rocket body. And startups works advanced norms, regulation, and incentives that contribute for the responsible use of the space. That will help. So already I told that one. That is end of life EOL, then active debris removal. So a lot of idea each and every country having. Then arbiter, that also one of the country they are having that support using this one. So most probably removal, how to removal the net capture, that also one system is available. using that. How you are capturing the fish, like that you can put the net and you can catch the debris, smaller debris to bigger, larger size also. So in atmospheric level, nowadays we are using the drone capture, that is anti drone. You can say that anti drone. So it will capture the enemy drones. That is identify immediately. It will go and capture, or it will test try on the spot itself. That is the one. The safeguard humanity orbital infrastructures using affordable area. That is the active debris removal. That is the very essential technology nowadays we are using. So try to use one. You see, smaller to large is 27. In 2022, they mentioned about that. Small to large is was factor of 27. That is, we can have that 1 and 10 centimeter. That is 1 million. So that is why I'm telling that is most of the things we have to identify, and government as well as the other government, other countries, they are generating fund for this one and putting the effort and the innovative idea to remove the debris. You see, in spacecraft itself, they are seeing that how the debris comes and where it is. Very small things. And this also space station, how it affect that things. Then for that reason only we are having the two arms in the IAS International Space Station for maintenance purpose and rectifying that smaller things. Then active debris removal. Already I told that these are the different category used to remove the debris. That is the laser based, depth based, satellite based, dynamical system. The dynamical system also very much useful, and people can utilize this one. Students can have the idea and you can use the collective, then ion beam, then sailboat, then unconventional. That means idea, and whatever you are having any idea that you can go for that one. You see, we are having the robotic arms that will try to capture that things. What is brown colors is available, sorry, orange color is available. Try to capture and put it in the dark. The gravity adds. Almost I told, so each and everything. So almost outer the purple color is selling that graveyard orbit. That almost dangerous, very dangerous one. Geostationary orbit. So graveyard orbit. So we have to think about that, where we are, how we are going to return. The cost of the space debris. So that cost also very much essential, and we have to think about that cost and we have to work it out. And moreover, even removal of small debris also will get the fund that will support the government. So you see, removal of small 1 to 10 centimeter debris, ground burst laser, space based laser, and the physical suit orbit, in the orbit, because whatever we are doing in the ground level we are sweeping, like that also possibility, because there is no force, we can easily move that one. Like water, any body is in the water means easily you can pull it, like that only, without any weight. That's why that is a removal of large debris. Tuck and control re-entry, move large debris. The sounding racket, that is already wrote Japanese things, we are doing that one. And the large debris tech management, recycling, and everything is available. So almost all the things we have to do everything using this one. So you see how scientists plan to turn space junk, that we have to think about and work it out. So first one is satellite capture, and second one is advanced robotic system, and third one is space foundry. So currently being developed. Then fourth one is the metal rods would be used to as a rocket fuel and in space electrical propulsion. That is electrical propulsion. Then we are having the space station, gas station in that will support to endurance, increase the endurance. So Airbus almost always they are doing a lot removal of debris in spacecraft. So launched from the ISS. So that's why I told, even from the Earth they are trying to remove the debris, and from the satellite, that IAS International Space Station, that also they are doing that one, vision based navigation. So what is available nearby, so try to do that one, and try to extend the arm wherever is possibility, and try to put the net, or we can have the laser beam also. We can send it the laser beam, then aerogel, so many items, so many technology. So you see the removal of debris, the net through the net. You see, even some videos available. You can go and see in the YouTube. So a lot of things available. How they are doing that one. From that, what we have some idea. We'll try to do something from our side. That also possibilities available. Only thing we have to think and work it out and do some research miniature level. So automatically you can get the support. Even international level, they are thinking of the bigger budget, so we can give small idea. So vision based navigation system, wherever is available, that is, we can, already I told that the maintenance, suppose we are telling that maintenance vision based machinery, by vision, by seeing that object, we are seeing that things, we can easy to dock the things. And then debris in the space or boom, that also possibilities. So almost we are having that, let's say, fired one satellite and plant mounted in a boom, and that will remove the debris from the spacecraft and traveling the speed of 20 meters per second, successfully impacted and penetrated the target, confirming the ability to capture the space debris. That is the Airbus that did. So almost the successful removal of debris, which is a harpoon, that is Airbus developed that one. Then ground based laser, already I told, from the laser, I try to remove the things, laser system. It may be from the earth, or sometimes it may be from the IAS. The space based laser, that's already told. Even easy to burn that one. Yeah. Even next one is sweeper things. What we did in the ground side, we can have the sweeper side. Then laser weight coins award system. Even if you are having that, means you can send the light and try to avoid the collision. That possibility is also, instead of removing that debris, that one possibility is there. That also things. The space based blower, that also nowadays we are having propulsion system. They are using that, using the blower type. So many debris available. So from this one, we can easy to control that one. And clean space one. So that's, I already told, you can send the satellite and capture that one. You see that one. Launch, ejection, approach, renderize, and then grabbing. Then we can disintegration. That means demolish that one or throw that one from the lower Earth orbit. So they clear the space. We are using the D-orbit and absolute satellite. Automatically, it will move in the space and it will capture the debris. This is the, you see the four arm is there, no? That easy to capture and put it to the satellite. That is the possibility. That is the first generated satellite was put it in the space. NASA also trying for the laser system. This also thermal runway. There is a gas lithium battery announced, that also you can have the burn the things. This again laser system from International Space Station. Net system, already I told, we can say that easy to take that tuck. That is, you can send the net with the very tether. Main connection is a tether, very strong tether, and put the net where is a debris available. Suppose the target satellite, you can see the first one target satellite. We are sending the net and with the tether, so automatically it will capture then and then pull it back. This also already I told that one satellite. It is easy to capture the debris using the foam arms. Descent, deorbiting spacecraft using electrodynamic tethers. That is the one I told, we have to send very strong tether, and then where is available, then it is easy to capture and pull it back and bring it to the spacecraft. So lot of things available. So I don't want to tell all the things. You just go through that YouTube, many things available, many technicals available. So you can have some idea, then you can try to do some mini projects according to your idea, innovative idea. These are the very very important informative things available, 500-meter and 8800-meter. So how the things is available and how we are commissioning the target. So range renderers, the close range renderers, then capture the stack configuration and deorbiting. So almost it was deorbiting and uncontrolled re-entry. That is, we are through this one, through the space. You see the things, even very bigger things also we can easy to capture using the net system also. The electrodynamic, already I told that one. Electrodynamic tethering system is very much essential, very much important, and very easy to do that one using the tether systems. The electromagnetic field also, this is the system easy to dock the that is the four arms and easily capture this. You see the space debris, left side we are having the blue color and right side we are having the micro satellite. Through that one folder arm is there, then through the electro things we are having the thing easy to capture that one. The same things how we are doing that one, that is a explanation given in the picture. Capture deorbiting, that is through that one. Like that only laser beam also, so many things. Laser orbital debris removal, that also it will capture you the things. Some force or impulse to the object and deorbited it whenever you needed, and the system uses the laser either on earth or the orbit. From the earth or the orbit, the laser things we can use from the earth or the orbit. The plasma solution also. Then we are having that end mass, that is electrodynamic, that is the third system, net system. Then we are having the system for the debris of towing removal. That's I already told that one. We are having net system, satellite system, laser system, electromagnetic system, and then tether systems. You see, laser system. Again I'm showing this one. I hope it won't be boring you. You have that idea. The space room, already I don't know, sweeping, how we are sweeping that land, like that only we can have this one. That also possibility, easy, that is the easy one. But we have to spend a lot. This globally we are doing that robotics. We are having the 57% hardware and remaining is software and services. We are doing that one. So how many debris available, you see that keep on increasing. So in 2025, already I told that one, it will reach around 26,000. Removal process, that is the one. Debris in the particle, we are having the tether system, laser system, the net system and satellite system. Based on that one, we can have that this laser system. So again I told that launch from the IAS. What is the statics? You see, 8,950 satellites and 5,000 satellites are still in orbiting. 1,950 satellites are meaningless. 500 collisions, breakups, explosion, that is available. Then 34,000 objects are greater than 10 centimeter. 9 lakhs objects are from 1 centimeter to 10 centimeter. 130 million object is less than 1 centimeter. You just think about that one, how it will be, how it will affect the objects, how we are going to launch in the near future the satellite to the space. Each and everything we have to do something. There is a space debris. I want to go for very fast and then we will show that. First, large debris also. We can have that analyzed in approaches, 5 approaches. Removing approach and controlled re-entry into the ocean through that one. So we capture, that means we can put it in the ocean. Remove the debris and control and re-entry. That is sending to the re-entry. The re-entry process is very much essential. laser, moving the debris with lasers and sounding rocket, then recycling debris, if possible, there itself into a propellant. So a lot of idea is available. So anything possibility means they can do, we can do, students can think and work accordingly. Even small debris to large debris. The small debris we are having that using ground-based lasers or space-based laser, and then physical sweeping also possibility. Small things you can easy to sweep that one and easy to capture that one. So these are the things keep on increasing year by year. Already I showed that one. So space debris, we are having that fission technology. Already I told junk food what we are having that one. The space junk, we are having that latest one, space junk, trash, debris, litters, and garbage. Then how we have to do that one? So how we have to rectify that one? Then artificially created objects in the space, most notably in Earth orbit, such as old satellites, still it's available, rockets available, different stages, different parts. So these are the things, the collision with other things. So for that, NASA has spent a lot of things, and they are categorized smaller to bigger size. Then they put the Sputnik 1 in 1957 by artificial satellite Russian. Our is Aryabhatta 1975. So many things. So the space stations available. These are the mission in the space station. What is the use of cell? Already I told that so many things. So communication purpose, location, internet, television. Reason for debris, the collision between each satellite, exploration of the satellites, imperfect settling of satellite, collision of meters and satellites, then due to unsuccessful launch of rockets and satellites. These are the satellites and space stations. So every times keep on increasing. Many countries are launching satellites on their own purpose and use repeatedly. And each and everything, once the duration, the expiry, because every time we are putting that 2 years valued or 5 years valued or 3 years valued, once valued still it will be roaming, that is orbiting in that space. That is the problem, and try to remove that one. You should just think, already I told that one, each and every year it keep on increasing the debris circumference. So exactly 70 years in the space exploration, we are having lost lot of debris. Then only things how we are going to remove that one. Disadvantage, not advantages, only disadvantages. As like I told, junk food, how it will create problem in your body. Like that only they are having that junk debris, space junk, space litters, everything they are try to damage the human life at such satellites. If not engineer, then become cleaner, space debris cleaner. So these are very fun things is possible. So near future, you have to think and work it out how to remove the debris. So already so many times that it came in the paper also. These are space stations. Is also already I told so many idea. So in that one, we are having that removal of the system, various system I told. So we have to predict and think and work and do some research and try to clear the things. So these are the impact analysis we are having this one. Emerging technology, already so many things. I don't want to tell that again and again. Orbital dynamics, collision, energy consumption, then deorbiting status, end life designs. This is the one, debris free space mission by 2030. That is, IS are planning to do that one. So almost all the students can join and plan and give your innovative idea and try to participate in competition and try to attend many program like this. And moreover, society, the astronomy and the space society and space club is available. So try to do that one. You just to think and see that how much debris available globally. Out of that one, we can go for that interesting things also. Whatever we are doing this one, lot of debris available. Apart from that one, some things we can go for the space farming also. That is very interesting one nowadays. Why it is needed? Even we are not doing anything in that earth, in land. Lot of land is available, we are not doing any farming. And why needed in the space? Yes, essential. And it should be reduce the reliance for the people who are stayed in the space station. And then mental and physical health, it will be supported for them, and helps close ecological loops. So it will give lot of information support to the people who are living in the space station. And moreover, in near future, if you want to go there, means almost all the people now are traveling to space. So, and all the countries are trying to search and finding that place whether it is human can live in that space. Once if you possibilities there, means surely it will be very useful. The agriculture thing is useful. That's why nowadays itself they are doing some examples, they are doing then some initiative, they are doing that one, that will give support. A lot of challenges available because we are having the innovative. So we are getting that high hydroponics. So that also it will be a small chemical things, it will be grow in the water. Like that only they are doing a lot of things in the idea and initiative by the government. Not only government, throughout the world globally. The challenges available: international space station, zero gravity. There is sun rises 16 times within 24 hours. You just think about that one. 16 times already. Ms. Sunita William has given that interview. So we are seeing that one 16 times within 24 hours. We are seeing only one time in Earth. So that is the one. So a lot of challenges available: limited space, resource delivery, microgravity. That moon 1/6 gravity. So challenge is radiation, limited resource, and partial gravity. That is very difficult. The Earth, we are having almost best extreme weather, limited resource. So almost everything is possible, nothing is impossible. Only thing we have to think and work and challenge the innovative things. So these are the possibilities of plants in space: hydroponics, microgravity, controlled environment, aeroponics, artificial lighting, air circulation, and CO2. So these are the timelines for space. You see, 1972, 2020. Now veggie is possible. Now they are planning to uh, plant the vegetarians. So apart from that one, I come to that point of the international standards. They launched in 1998. That is 400 kilometers above Earth. So already I told 6 people is maximum, possibly 6 people is the short duration. But only thing 4 people can accommodate very comfortably. Research lab, solar arrays, life support system, then international collaboration, NASA, Roscom, as already I told that one, 4 countries or 5 countries involved in that one. Life and research on the ISS, experiments, key achievements, astronauts routine, missions. These are the things happening in the ISS. People are doing, whoever stayed in the ISS, they are doing something for the global advancement. So what are the things growing threat of the space debris? So already I told so many things is small size and bigger size also available. That will be very soon, it will keep on increasing. then it will affect the human life as well as the satellite system over. And today and tomorrow, what do we have to do? Tracking, shielding, policy, removal. So almost you come to the point, all the things, try to remove that things. That is the one almost we need, and the globally needed, and the global community also working on that one. Let me come to the point. Really, I thanks to our management and especially our chairman, Dr. Anand Jacob Varkis, and our director, Annie Jacob, and a deputy director. Almost all are very much involved in the aviation field. All of you know about that one. Hindustan Group of Institution is more than 50 years in the aviation field. So mainly they are supporting the things and motivating the students. We are having the space center, that means satellite center. So we are planning to launch on satellite very soon, already is in progress through our student support as well as the scientists. And these are the guys, students are involving themselves, and they are doing something real-time environment designing and AI processing, microclimate prediction. And I hope I can show one video about the our program and our about our things. Purely this is student-based project, and moreover, one of our alumni, the supporting entrepreneur, they are supporting. So two things is available. One is one of the, you can see that. After that, you can discuss.
Oh, sir, are you showing
Yes,
the
sir.
video?
Yes, sir. It's audible.
Yeah, I can hear you, but you told that you will show some videos.
Yeah, video is running. No,
No, I can't see it, but I don't know some others.
no. Is he able to see the video or not?
I could not see the video.
I don't know,
Uh,
but it is visible.
Only slide is visible, sir.
Sir, this
yes,
video is not
the slide.
visible.
Only the slide. The last slide is visible.
Now it's visible. No, now it's visible or not?
No, no, not yet visible.
Why say? But it was connected. I don't know how we go to do things. Video is running here. It was connected with
Okay.
that only. How I have to include that one?
No, no issue. If it's possible, we can show them.
Sir, stop
Um,
the record video, the
Ah,
screen sharing video.
ah.
Then please share again, sir.
Stop the
oh,
share.
sir.
Yes, sir.
Yeah,
Yes,
you
sir.
can restart the screen and then play the video again.
One minute, sir.
Video மட்டும் just conduct question answers.
Video alone I have to show. This is the one you are seeing, that one. Sir, now this PPT is visible.
You can reshare the screen one more time.
Okay.
Now it is not visible. You can reshare again. Then you try to play that.
It's okay, sir?
Now we can see the screen.
Now I can see the. This is the video link, sir. Now I can.
You can share. You can play that. Now it is. Yeah, it is coming.
Yes, sir. Yes, sir. Is audible visible, sir? Sir, is it visible?
Yeah, it is visible.
Yeah, thank you.
Sir, audio is available, sir? Video?
Yeah, it's available, sir.
But video only we can see. Sir, stop the sharing and then
Stop the share. Okay.
again share. Wait a minute. The video sound is enabled.
Hello.
டைம் ஸ்பெண்ட் பண்ணலாம் பார்த்தா
Sir, 1 minute, sir.
யாருமே வேற ஒருத்தர் பிரசன்ட் பண்றாரு. நான் கன்சாலிட் பண்ண சொல்லிருக்காங்க. ஐயோ.
Sir, is audible? Sir? Sir, whether it is audible?
No,
Sir,
sir.
I'm student Jagannathan.
Yeah.
Sir, we can't listen the audio, sir. Could you please press the audio button in the display? Yes, that
Now
one.
okay?
No, sir, we didn't receive the audio.
சார்
Audio only.
ஆக்சுவலாக அந்த ஷேர் பண்ணுற போதே அதில் கீழே பார்த்தீங்கன்னா வீடியோவோட ஆடியோ எனேபிள் பண்ணுற ஒரு ஆப்ஷன் வரும் ஷேர்
சரி,
பண்ணுறது.
இதுலயே இது ஆடியோ கட் பண்றேன். இப்போ இந்த சார் இது தெரியுதுங்களா? whether you are seeing that photo?
வீடியோ தெரியுது சார், ஆனால் ஆடியோ
இவங்க இது ஆடியோ I am removing this one.
இல்லை சார், நீங்கள் ஷேர் பண்ணுறீங்கல்ல ஸ்க்ரீனை.
ஆமா.
ஷேர் பண்ணுறப்பயே ஒரு ஆப்ஷன் வரும், வீடியோ அண்ட் ஆடியோ எனேபிள் பண்ணுற மாதிரி ஒரு ஆப்ஷன் வரும். அதில் டிக் பண்ணியிருக்கணும் நீங்கள் சவுண்டை.
Okay, as we are running out of time, Professor.
Yes, sir.
Shall we take questions? Shall we take questions from the?
Yeah. We will another 2 minutes time, sir. I will complete that one.
Okay.
So I know that is a tough time. I will possibility to know that. I don't know why it happened like this.
So, students, meanwhile, you have, if you have any doubts related to this session, particularly this session, and
So
you
one
can
more
ask
thing also we
questions.
are having.
You can
These
share
are
your
the
question.
things, and this also I don't know how you to choose one. This is our students project. They designed. This is the our alumni, and they are having the startup program. And using this one, they put aerostat, and it will reach you up to the stratosphere, and you can find out from there itself the image. You see the this side, almost you can easy to order. This is the first time we are doing in our college. Based on that one, earlier we planned. Now that DRDO is doing the same project, so we our students, that also once again it is a small video, but I don't know whether it is visible or not. I don't know. Two minutes time, sir. Is it visible, sir? Sir, whether it is visible?
Yeah, aerospace technology.
Yeah.
That's the green technology that I can see.
Yes. It's no audio, only video. Using this one, we can reach up to the stratosphere, 36,000 altitude. So from there, it is using the AI, artificial intelligence. We can do something. That is our project, our students' project. Like that, we can plan very easily. So I like to support for all the students. So these are the lot of things we are having, using the requirements of orbit. So due to the time shortage, so I would like to show the geostationary orbit and stationary orbit. So we are having the some support. Conclusion: science can make wonder. Today dreams are the tomorrow reality. Pursue your dreams with passion, hard work, and dedication. As you are young, you have no boundaries, no hurdles, no hesitation in thinking. Your dreams and thoughts makes impossible things possible. Several mind-blocking technological innovation can bring in drastic change in the life of common men. Put all your efforts to bring the full power of the technology and the new wealth created to improve the life of everyone in our country. Learning throughout the life should be your guiding principle. So these are the space technology. So we have to use for that one. And one more things also we are having. So time shortage of these things. I think Ravi Kumar also participated for Chandrayaan 3. Is audible, sir?
Yes, sir, audible.
Video is there.
No, only slide is there.
Okay. This one, then I will continue one because you are having the video, the YouTube. Okay, I think Ravi Kumar sir also participated. You see that his video is available, is visible.
No, sir, I could not see your video.
Only
Only the
audio is
last
coming.
slide is
Yeah.
there. Okay, there is a link for video link, YouTube video link, but but no video is available.
Okay, sir. Okay, sir. I will complete this one. Okay, thank you. Any questions?
Students, we sincerely appreciate the effort of Dr. Vijayaraja, Professor Vijayaraja sir. So almost he covered the entire aspect of how to do a project in space and science technology. So here now, if you have any particular doubts related to this, you can ask your question. You can unmute your mic and then you can ask question. Otherwise, you can use chat box. You can type your question in the chat box. Professor, you can answer the
Yes, sir.
questions
Yes, sir. Yes, sir.
from through the chat box. But the
Okay,
session
sir.
was
Okay, sir. Okay,
excellent
sir.
and your talk was covered almost everything. So thank you, Professor. Very excellent presentation. There are one or two questions are there in the chat box,
Okay,
so
sir.
you
I will
can
try to
answer the
answer for that.
question. Yeah.
Hello, sir.
Yes, sir.
It's been a pleasure to connect with you, sir. The speech you made is extremely informative to us. I'm Ahmad, working in the NASA Gene Lab, analysis working group. So, I'm recently started a startup in the airborne systems, which you mentioned in the space agriculture. So, for the part of the systematic approaches, I need to develop a cleanostat. Can I get any collaboratives from your college, KCG? Is this possible, sir?
Yeah, please visit our campus, and whenever you are having time, and we are having the space center, that is satellite center, our students are working in that one, and they are starting from the CubeSat small things to what I show that one aerostat, that progress is going on. And why we are
Okay, sir.
having that satellite center means we are lucky enough to monitor 75 satellite, because the government is going to launch 75 satellite through the Atmanirbhar, so that we are having the opportunity to monitor all the 75 satellites in our lab itself, our the space center, satellite center itself. So better you can visit anytime, you can visit our college and you can see that one, and surely we will do and guide you and support you.
Okay, sir. Can I get your mail ID for further proceedings?
Yes, yes, yes. HOD
Yes.
arrow at the rate of kcgcollege.com. Shall I
HOD
type that
arrow
one?
at.
Shall I type this?
Okay, sir. It's fine. Thank you.
Yeah, this is the one. HOD arrow at the rate of kcgcollege.com.
Okay, sir.
Yeah, that one student has asked what is the success rate of the destroying the debris completely. So that is one, that is I think Ebenezer Joshua. Ebenezer, that is the one. Every countries, all the countries almost they are doing their uh, innovative idea. They're utilizing the innovative idea, try to capture and destroy the debris in that small level only, not exactly, not perfectly. So still the research work is going on. So very soon it may happen. That is already our India is planning that 2030. Like that, all the countries they are involved with themselves according to their own technology. Yeah, we can deviate the orbit. That is PC school. We deviate the orbit debris to the sun. So I don't know whether it will be work it out or not. That we have to think about that. What is the procedure? Change the topic name. I don't know what is the topic name. Yeah, laser method. Ebenezer, again Ebenezer. Laser method is possibility that to from the earth or from the IAS, International Space Station. Santosh from IIT, NIT. Almost ISRO is recruiting all the people, all the students, those who are having GATE score. So I would like to inform engineering students, try to write the GATE examination. The GATE examination, easily get into the things. I don't know sun center temperatures. I don't know that is. I don't do have any idea to do that one. Yeah, that's why micro. I already identified. They identified less than 1 centimeter also. So a lot of innovative idea is there. Country they are doing. Yeah, PC school again. Opportunity for us astrophysics available even in India and abroad also. A lot of PG courses select even completion of engineering degree also. One of our students is doing that astrophysics. Here they join. Mother again asked. Go and see that website that it can easy to identify that one. Yeah, Rahul, lot of opportunities available for internships. So you can go and see that ISRO, VSSC, SAR Center. So in the website they are having internship. Surely you can get all the students get the internship. You can ask your professors.
Dear students, please ask question related to the Yassc. It is the main purpose is to do a good project
Ebenezer,
in
sure.
Youth Academy Science
Through the
Center.
GATE examination, surely we can become the
So if you have any questions like this,
scientist,
we can
ISRO
have
scientist.
interaction with the
Manohar sir,
professors.
Ravi
So
Kumar sir.
you can ask.
Yeah.
Ravi,
Thank you very much for your valuable time spent with us. So I have to thank to the
thank you,
Yassc
Professor.
and Tass sir, Dr. Ravi
So
Kumar
thank you,
sir,
Professor,
and
for
support
having.
to the colleges, that is 3C colleges as well as the Sivakasi colleges. College
So
college
we
plus
have
the
planned to conduct one orientation in the.
colleges.
Okay, so Professor has given excellent presentation and addressed all your questions. So with this inputs and discussion, we shall wind up the session. So Professor, shall we wind up the session?
Yes sir, please.
Dear students, there are some questions how to publish your article. There is organizations are there the people from the organizing structure. They will call you and they will give a link to publish your papers. You can share your paper. First of all, you have to complete your research paper, and there is orientation. This is the orientation program. After some orientation program, and we have an interim workshop. Interim workshop means, so after completing some works, they will give some inputs. In there, they will tell you how to finish the paper in a exact paper format. So we will share a link, or we will share some some email ID. To that you have to send your paper. Okay, that will be discussed in after some time. This is the ideas we are giving. This is the orientation program. This during this orientation program, you will get an idea. You have to select your topic, and you have to do. You have to start your literature survey and then start writing a paper. After starting all those things, and we have interim workshop. During the interim workshop, we will help you how to complete as a paper. Then we will have a zonal level congress. During the zonal level congress, you people are coming and presenting your paper in front of the other research scholars as well as the evaluators. So we will invite the evaluators from various places, scientists, professors. So in front of them, you have to explain your presentation. Okay, then they will ask some question. Based on that, you will selected for the national level. So during the national level, some of your best projects can be consolidated and published as a souvenir, as a special souvenir. So in order to make as a proper souvenir, your paper should be as valuable as possible. Otherwise, we cannot select. So that is why this kind of orientation will help you to how to select a paper as well as how to convert the topic into a decent papers. That is why we are inviting professors like Dr. Vijay Raja, Dr. Ramanujam, okay, Dr. Joseph Prabhakar, Dr. Neeraj Ramanujam Mogan, Dr. T. Venkateswaran. So from this input, you have to select your topic. So don't bother about when we have to submit, when you have to publish, how to get a job in ISRO. That is not concerned here. Okay, so hope you understand. So please select a paper and we have organizing structure. So professor and myself are academic session. There is an organization section. Each and every students are selected. I mean, you are consolidated into different districts. So you have a district committee will call you and they will ask you to refine your projects. So I think up to now, I think you may get a call from your coordinators. Have you received a call from coordinators? Anybody? Can anybody respond me? Have you received call from your zonal coordinators? No. Which district you are? Please mention along with the district. Please mention along with the district. Okay, Tiruvarur. Okay. So I already told you. Let me explain. The registration time was extended up to 30th of June. So after 30th of June, the zonal coordinator will call you. They will assign a special number to you, and based on the number that is called registration number, then they will tell you what to do. So this is the orientation program for state level. So there are hereafter you have a orientation program in this zonal level. Okay, if you understand, please say yes. If you understand this, please say yes. Please say yes if you understand this. This is the orientation program. We have a request from the so many colleges because the colleges are reopens at June 15. No, they want at least 15 days. So that is why we have just extended the date 15 days. So the childrens will register till June end. So thereafter, then the districts will consolidate, and then they will call you one by one. So one by one. So in that cases, they will tell you what to do. So this is the orientations. Next month you have one more orientation. In that orientation, we are going to cover some special competition like astrophotography, okay, e-content, astronomy e-content, and then what you call as poster presentation, as well as games, astro games. So you may have my number. Okay, so you please go and check the brochure. There you have numbers of all the academic coordinator. If anybody doubt, please call me personally, or you can call Mr. Udayan personally. If you have do you have my number? It is there in the brochure. Otherwise, I can share my number. This is my number. My name is Dr. K. Ravi Kumar. I am the academic coordinator for this program. So I already told you the date was extended up to 30th of the June. So after that, you have the coordinators from the different district, and they call you. Okay, with this I can stop at this point. Thank you, Professor Vijay Raja, sir, for spending your
Thank you.
most valuable time with us and giving a lot of insight to the students to how to do projects in the space and science technology. So thank you very much. We also thank
Thank
to
you very
Bishop
much.
Huber College for having uh, for giving this link, and thank you to all. So we can end now. Thank you.
Okay.